Hello everyone, myself Pandiye. I'm studying in Sri Venkateswara College of Engineering in Bhaskara section, and my USN is 1V22CS108 in third sem from the branch CSC. Today I am here to discuss the topic multi-threading programming in the operating system. These are the topics to be covered in this PPT. The first one is introduction, then motivation, then benefits, then multi-core programming, multi-threading models, many to one to one model, and many to many model. First of all, introduction. Let us discuss some of the topics about introduction. A thread is a basic unit of CPU utilization. It consists of a thread ID, a program counter, a stack, and a set of registers. Traditional processes have a single thread of control. It is also called as heavyweight process. There is one program counter and one sequence of instructions that can be carried out at any given time. A multi-threaded application have multiple threads within a single process, each having their own program counter, stack, and a set of registers, but sharing common code, data, and certain structures such as open files. Such progress are called lightweight process. Then motivation. Under motivation, let us discuss some of the points. Threads are very useful in modern programming whenever a process has multiple tasks to perform independently of others. This is particularly true when one of the tasks may block and is desired to allow the other task to proceed without blocking. For example, in a word processor, a background thread may check spelling and grammar while a foreground thread process user input keystrokes, while yet a third thread logs images from the hard drive and a fourth does periodic automatic backups of the file being edited. In a web server, multiple threads allow for multiple requests to be served simultaneously. A thread is created to service each request. Meanwhile, another thread listens for more client requests. In a web browser, one thread is used to display the images and another thread is used to retrieve data from the network. What are the benefits of using multi-threaded programming? The four major benefits of multithreading are responsiveness. One thread may provide rapid response from the other threads or block, doing own intensive calculations. Multithreading allows a program to continue running even if the part of its block or is performing a lengthy operation, thereby increasing responsiveness to the user. Then second one is resource sharing. By default, threads share common code, data, and other resources which allow multiple tasks to be performed simultaneously in a single address space. Economy. Creating and managing threads is much faster than performing the task for the same processes. Context switching between threads takes less time. Scalability. Utilization of multiple processor architectures. Multithreading can be greatly utilized in a multiprocessor architecture. A single-threaded process can make use of only one CPU, whereas the execution of multi-threaded application may split among the available processes. Multi-threading on a multiple core machine increases concurrency. In a single processor architecture, the CPU generally moves between each thread so quickly as to create an illusion of parallelism. But in reality, only one thread is running at a time. Then, what is multi-core programming? A recent trend in computer architecture is to produce chips with multiple cores or CPUs of multiple chip. A multi-threaded application running on a traditional single-core chip would have to execute threads one after another. On a multi-core chip, the threads could be spread across the variable cores, allowing true parallel processing. For operating systems, multiple core chips require new scheduling algorithms to make better utilization of multiple cores which are available. For application programmers, there are five areas where multiple core chips present new challenges. First one is dividing activities. examining applications to find activities that can be performed concurrently. Second one is balance, finding tasks to run concurrently that provide equal value. You don't waste a thread on trivial tasks. Data splitting, to prevent the thread from interfering with one another. Data dependency, if one task is dependent upon the results of another, then tasks need to be synchronized to assure access in proper order. Testing and debugging, inherently more difficult in parallel processing situations as the arrays become much more complex and difficult to identify. Then, what are multi-threading models? There are two types of threads to be managed in a modern system: user threads and kernel threads. User threads are threads the application programmers would put into their programs. They are supported above the kernel. Without kernel support, kernel threads are supported within the kernel of the OS itself. All the modern operating systems support kernel level threads, allowing kernel to perform multiple tasks simultaneously. In a specific implementation, the user threads must be mapped to kernel threads using one of the following models. There are three types of models in operating system. The first one is many to one model. In many to one model, the user level threads are mapped onto a single kernel thread. As you can see in the diagram, there is only one kernel thread which has mapped to four different types of user threads. Second one is, and advantages of many to one model is, thread management is handled by the thread library in user space, which is very efficient. And one of its major disadvantages is, if a blocking system call is made by one of the threads, then the entire process blocks, thus blocking the other user threads from continuing the execution. Only one user thread can access kernel at a time, as there is only one kernel thread. Thus, the threads are unable to run in parallel on multiple processes. Example, green threads of Solaris and GNU portable threads implement the many-to-one model. One-to-one model. The one-to-one model creates a separate kernel thread to handle each user thread. As you can see in the diagram, there are different user threads to a kernel thread. It is not linked to the same kernel thread. And the advantages of one-to-one model is, it provides more concurrency by allowing another thread to run when a thread makes a blocking system call. Multiple threads can run in parallel on multiprocessors. Disadvantages is, creating a user thread requires creating the corresponding kernel thread. This model places a limit of number of the threads created. Linux and Windows from 95 to XP implement the one-to-one model for threads. Many-to-many model. The many-to-many model multiplexes any number of users thread onto equal or smaller number of kernel threads, combining the best features of one-to-one and many-to-one models. Users have no restrictions on the number of threads created. Advantages: developer can create as many user threads as necessary. Blocking kernel systems calls do not block the entire process. Processes can be split across the multiple processors. Individual processes may be allocated variable numbers of kernel threads depending on the number of CPUs present and other factors. This model is also called two-tier model. It is supported by the operating systems such as IRIX, HPUX, and True64 Unix. Thank you. If you do like the video, please like, share, and subscribe.